OK, last topic for today is caching. The fastest database is the one you don't use. We've said all along that the database is one of the bottlenecks you can't just scale your way out of. So a good way to avoid that problem is don't use the database, which is not as hard as you might think, because a lot of times you'll repeat a query whose answer hasn't changed since the last time you did that query. And in any caching scenario, you sort of have to solve two problems. One of them is, how do you know what to cache? And in our case, what we'll see is in a software as a service app, there's two natural things that you could cache, which is basically an entire view or a chunk of a view. And how do you know when to get rid of stale versions of things? In other words, if the original value has changed out from under you, you need to invalidate or throw away the cache copies and do the work to regenerate the real copy. And in SaaS applications, there's actually a number of places where you can cache and different things that get cached at each point. So if we actually start all the way from the end user, the browser, as you probably know already, has its own cache for complete pages that you visited that haven't changed. If you don't hit there, you might hit the web server next. And as we'll see, the web server can also cache copies of pages that, from the server's point of view, haven't changed recently. If you don't miss, or if you don't hit in the web server's cache, there's the opportunity to cache the results of controller actions. Right now, we're kind of in the realm of we're relying on the model view controller architecture. If we can't cache a whole page at a time, we're going to ask, what can we cache about the individual pieces, the models, the views, and the controllers? In the case of a controller, remember that every controller action results in rendering something. And often, you can save the work of re-rendering it if the result of running that action would not have changed. If that doesn't work, you've still got two other options. One possibility is, well, maybe the controller action didn't give the same result, but the view that you're rendering has at least some parts of it that haven't changed since last time. And because you're nice and dry and you've made your views out of partials so that you can reuse the chunks that are common across different views, there's the opportunity to reuse a chunk of a view even if you can't reuse the entire view. So you get some partial benefit there. And if that doesn't work, lastly, what is a model? It's a data structure backed by the database. And the database also has a cache of recent queries that it manages all by itself. So sometimes running a query like movie.all, if you haven't added any new movies to the database, the result of that query hasn't changed. There's no reason to redo the query against the live database. So these are all examples of places where you can intercept a request and return a cache version rather than doing more work. So the first two of these that we can talk about is page and action caching. And what these have in common is that they both cache the output of the entire action. So the controller action will generate an entire HTML page. We've been using Haml. And there's two different cases of how you might want to handle caching for that. There are some controller actions that are not protected by any controller filter. That means anybody going to that controller action essentially is going to see the same thing. So in those cases, it makes sense to just cache the entire page. In fact, Rails doesn't even have to get involved in those requests. What actually happens is that Rails works with the presentation tier, with the web server, to make sure that the static HTML corresponding to what got generated for that page is cached so that future requests don't have to refresh it. And we'll talk in a moment about how you expire it. The difference between page and action caching is that in action caching, you run the filters first. Basically, you allow Rails to get involved. And the reason you might do this is that there are some controller actions that, as long as the controller filter allows the action to proceed, you would get the same output. So it would be OK to cache it. But you still need the filter in place because not everybody's allowed to do the action, or because the action might behave differently depending on, let's say, whether you're logged in or not, or whether you're logged in as a regular user or an admin user or something like that. So a caveat for this is that the name of the page as named by the URL is basically what's used as the caching key. That means that from Rails' point of view, if you've been using this mechanism to add arbitrary parameters to a URL, these don't affect the way that the URL is put together for caching. So what that means is that if you had different views that could be rendered, or a difference in how the view would be rendered, depending on the presence of specific parameters, that might break the caching subsystem. It's yet another argument to try to standardize your RESTful routes as using components of the URL separated by slashes in the path as part of the name, because that makes the URLs different from a caching point of view. Because of the difference between page and action caching, that whether Rails gets involved to run the filters or not, a caveat is you also don't want to mix filter and non-filter code in the same action. So what do we mean by that? If you look at the example on the left here, I'm using the caches page directive to tell the controller, once you've generated the page corresponding to this action, it's fine to hand that off to the web server. And the web server can serve future copies of it until I tell you it's changed. Unfortunately, the controller action that generates that has this code path that depends on whether you're logged in or not. And presumably, it will do one thing if you're logged in. If you're not logged in, it'll do a redirect. So it's actually semantically wrong to apply page caching to this, because whichever user happens to generate the page first, whichever code path gets executed first, that's the one and only one that's going to be cached. What we would really like to do is separate this out into two different actions. For example, a public index, which is what you get if you're not logged in, and a logged in index, which is what you get if you are logged in. So now we've got two separate actions. For the one that's publicly viewable, we can use caches page for that, because it doesn't matter who's accessing it. It's going to render the same thing. But for the logged in index, which depends on whether you're logged in or not, this one can be protected by a controller filter, and we can use caches action for that. So what's the difference? In both cases, the thing we're going to cache is the output of running the entire action. But when we're using caches page, Rails ignores the request once the cache has been set up. When we're using caches action, Rails gets involved at least enough to check if the controller filter would have to run. Now, what if you can't cache the result of an entire controller action at once? For example, if you've built a view out of multiple pieces, you might be able to cache the result of rendering pieces of that view, even if the view as a whole is assembled differently for different users. So that's when fragment caching can help you. Fragment caching essentially lets you cache HTML chunks resulting from rendering part of a page. And the way you use it is you put the directive right into your view. You can put a do-end block inside of a cache, and you can essentially assign it a name. This is the name that's going to be used as the fragment name in the cache. We'll need this later, because we also have to make sure that when a fragment is no longer valid, in other words, here we're caching the list of all movies along with their ratings, but obviously whenever we change the list of movies, the fragment corresponding to this chunk could change. So we can assign basically an arbitrary name that we want. We're going to call it movies with ratings in this example. And now, because this is inside of a cache block, let's take a look at what the code would look like for this. So how do we know if we're going to cache fragments of a view? How do we know when it's time to expire the fragments? In other words, when are the cached copies no longer valid? Well, Rails makes very good use of the observer design pattern, which we talked about briefly in our discussion of design patterns. Recall that observer is what you use when you've got a separate class that wants to be notified when something interesting happens in the subject, the class under observation, but you don't want to have to modify the subject class in order to do it. So this is exactly an example of that scenario. We have a movie sweeper class, which is all about caching things associated with movies. And we don't want to modify the movie class, but we want to be notified when certain interesting events happen. And in our case, a natural thing we could look at is whenever a new movie is created or a movie is updated, or if a movie is deleted, those are things that would cause the fragment corresponding to the list of all movies to no longer be valid. So what we've done here is we've set up a movie sweeper, which inherits from a cache sweeper. This is part of the Rails framework. And we've optionally, just for clarity, I've put observe movie, although as you might have guessed, because Rails uses convention over configuration, even if we left out observe movie, Rails would infer from the name of the class movie sweeper that the thing we're observing is movies. So this is another example of when you could override that if you wanted to name the class something else, for example. The way that these sweeper classes work is we can basically define all of the same callbacks that the active record lifecycle defines on the subject class. So remember, we have a before destroy, we have an after destroy, a before save, an after save. All the same callbacks can be used. And these are going to be in addition to whatever is already in the movie class. So this says whenever a movie is saved, after the movie's own after save callback is called, I have one that I want to call as well. And in our simple example, we've defined an invalidate method, which just says expire if you have any cached templates, any cached rendered views corresponding to either the index action or the show action, expire all of those. And if you've got any fragments that have the name movies with ratings, expire that fragment as well. And if you recall, that's the name that we gave our fragment in the example. So this is a really simple example. And by the way, you have to make sure to tell the controller that you're doing caching. Cache sweeper is basically what instantiates the observer design pattern here and says, I'm providing a class that is going to take care of invalidating cached copies of the things that I'm watching. So this is sort of a minimal example of how you can use fragment caching and action caching in Rails. Like with any kind of caching, you have to worry about how you're going to name the things and how you're going to decide when you have to expire them. Expiring them is your own responsibility, right? There's no way for the app to be able to tell in general when a particular fragment or a particular action might become invalid. So you have to think quite carefully about what the conditions are that might cause any of the cached objects that you've created to become invalid. And you have to declare which callbacks you want to use on the observed model to make sure that you get a chance to invalidate them. Okay, so like we said, we previously had talked about the observer design pattern, and this is exactly an instance where the subject is an active record class that's one of your models, And the observer is a pattern. It's basically a generic interposition mechanism. This is what ships with Rails. And by subclassing it, we created a subclass movie sweeper that observes interesting events on movies and uses those events to trigger the cache, to trigger the invalidations. So how much does this help? How much does it help to actually deploy caching in your app? Because remember, the goal of our exploration of platform as a service is what are all the tricks we can do so that for as long as possible we can stay in this nice world where a lot of the infrastructure is curated for us. So here are some measurements that were taken on essentially the bare bones Rotten Potatoes app. What we did is we pre-populated it with about 1,000 movies and about 100 reviews for each of the movies. And then we ran the app on Heroku and did a bunch of requests against it to see how long, in other words, the x-axis here is the response time in milliseconds. How long did it take to serve a typical show action? And when we turn on page caching and action caching, basically for the list of all movies and for the show template for each movie, compared to having no caching, we can fetch things 8x to 21x faster. Roughly speaking, that means we could serve 8x to 21x as many users with caching turned on as if we didn't have caching. So it's like getting a free order of magnitude if you manage your caching correctly in terms of the number of users that you can serve with the same amount of hardware. That helps us stay in the past here for a little bit longer. So here's a question about caching to see if you understood these concepts. Suppose we have under 17 visitors visiting Rotten Potatoes. We don't want them to see any information about movies that are rated NC-17, because presumably they wouldn't be allowed to watch them anyway. And we already have a controller filter that correctly determines if a user is under 17 or not. So which kinds of caching could be deployed that would still be consistent with this goal? We have a choice of page caching, action caching, and fragment caching, as we just saw. And keep in mind that you can combine the different types of caching in one application. So which kind or kinds of caching would be appropriate in this situation?